motion in plane now. Before that, the beginning, what is required is again we have to write the what is that position and displacement vector. Position and displacement vector. Okay, so many times we have gone through these words, but again we have to go through this one. Okay, so now we have to write the position or displacement vector. So far we used to give in only one vector. Now we have to write that vector in the components form. Okay, suppose you are having some x and y axis. So plane means you have to use two coordinate axes. Okay, so this is what your x and y axis. Okay, so suppose you are having a point P over here. Okay, this is the point P, and say it is at a distance r from the origin. Okay, so this is what x and this is what y. Okay, so now we have to write this r in the component form. So this is what the position. So how we can write the position? Now you can take say here. Okay, so I this. So what will be this distance? Say it will be say some x. Okay, then this will be say some y. Okay, so now this is not just magnitude. If you want to convert into what? If you want to convert into a vector, so you have to write x I cap, and this you have to write y j cap. Okay, so now the position vector r, how you can write? You can write r equals to position vector r equals to, so x I cap plus y j cap. Okay, x I cap and y j cap. Okay, so this is what going to be the position vector r of the particle P. Okay, you may ask me then what is x? If you know this angle theta, so x you can get. What will be the x? X is nothing but it is r cos theta. Okay, so x is going to be r cos theta and y is going to be what? R sin theta. Okay, but since they are not mentioned theta or the angle, so no need to go through this one. So that we can write r equals to x I cap plus y j cap. Okay, so this is what the position vector. Now suppose if there is one more point, suppose the situation is something like this. Okay, so here you have the point P. Okay, this is what your point P, and say what is distance? Say its distance is say r. Okay, after some time this point will come here. Okay, so after some time this point will come to this one. So this is what let me take this as P dash. Okay, in time delta t, in a very small time, the point moved from here to here. Okay, so this is what the P dash. So P dash, let me take over here. Okay, so this is what P dash. Okay, so let me take this as R dash. Okay, so R dash. So this position vector is R dash. Then how we can write for the R dash? Okay, so if I have taken this as x, so let me take this distance. Let me take this distance as x dash and this distance as y dash. Okay, let me take that as x dash and y dash. Okay, P is going to be here. Okay, so now, so how we can write r dash now? X dash and y dash are the components. So r dash will be, r dash is equals to, so what you can write? X dash I cap plus y dash j cap. Okay, x dash I cap plus y dash j cap. Okay, so this is what going to be your position vector for P dash. Okay, position vector when the object is at a point P dash. Okay. So these are what position vectors. These two are going to be what position vectors. So this was when t equals to 0. This is when t equals to t. So means it is after time interval delta t. After time interval delta t, this becoming like this. It is becoming r dash equals to x dash I cap plus y dash j cap. Okay. So this is what your new position vector. Okay. So now after delta t time, what is happening? The position is changing. Position vector is changing means what? Position is changing. If position is changing with time, then we can say that object is in motion. When object is in motion, then you have to express what its displacement, how much displacement it is that has taken place in a small time interval delta. Okay. So what is displacement? Displacement is here. So these are the vectors, means you have to show the directions also. So okay. Now this is what the displacement. This is what the displacement. Okay. So it doesn't mean that particle must have gone in straight line only. Displacement means we have to take the straight distance from initial to final position. But object may be gone like this also. Object may be gone like this also. Okay. So object may be gone like this also. But this is what distance. What we want displacement. Okay. So for this displacement, how we can write the displacement of point P in a small time interval delta t. So this displacement I will take it as delta r. That displacement I am taking it as delta r. Now we have to write the expression for delta r. Okay. Now I will take this triangle outside. You will understand what is actually happening over here. Okay. So one vector is in this direction, another vector is in this direction. This is what delta r. This is what the direction. Okay. So this is r. This is r dash. Look at the r dash and delta r. It is going to be what the triangle of vector addition. It is going from here r plus delta r equals to, these two are in same direction, head to tail. So again here head to tail, but this is in opposite direction. So this is going to be resultant. Okay. Then what is delta r? Delta r is going to be r dash minus r. Okay. So very very important equation. Remember, delta r is equals to r dash minus r. Okay. Delta r is equals to r dash minus r. Now substitute the value for r dash and r. So what is r dash? R dash is x dash I cap plus y dash j cap. X dash I cap plus y dash j cap minus what is r? R is x I cap plus y j cap. X I cap plus y j cap. Okay. So that is what the r, and this is what r dash. Now what will be the resultant? Resultant delta r or delta vector r, you can write as x dash minus x. You can make x components on one side, y components on one side. So x dash minus x. So common is what I cap plus y dash minus plus y, minus y dash minus y into j cap. Okay. So this is what going to be your displacement vector. So if you want to make it more simple, delta r equals to, so what you can write, x dash minus x. What is x dash minus x? This total is x dash. From here to here it is x dash. Then this is what x. From here to here it is x. Then what is x dash minus x? X dash minus x is nothing but this one. This is what? Delta x. Okay. Similarly from here. Okay. So from here, this is y dash. This is what? Y dash. Okay. Then what is y? From here it is 1. Okay. So from here it is 1. Y dash minus y. This is what going to be delta y from here to here. This is the small displacement. The small y component is going to be what? Your delta y. So I can substitute x dash minus x equals to delta x. X dash minus x equals to delta x, and y dash minus y equals to delta y. Okay. So substitute here. So delta x I cap plus delta y j cap. Delta x I cap plus delta y j cap. This is what going to be the displacement vector. Okay, for the particle moving from P to P dash. Okay, where delta x is x dash minus x, delta y is y dash minus y. Okay, so remember the position vector delta r is going to be delta x I cap plus delta y j cap. Okay. Now we'll go with next. What has happened? Position and displacement. Now we can go with the velocity. Okay. So velocity we can express in terms of vector or I cap j cap. So what we got position vector, we got it as like r equals to x I cap plus y j cap, or r dash we got it as x dash I cap plus y dash j cap. Okay. So similarly, so what we got for displacement we got it as delta r equals to delta x I cap plus delta y j cap. Okay. So again delta x equals to what? X dash minus x, delta y equals to y dash minus y. So this is what we have discussed so far. Okay. So position vector and displacement vector. If there is a displacement, obviously there will be a velocity. So how we can define the velocity or average velocity? Let me take the average velocity. Okay. So average velocity. So how we can define the average velocity? Average velocity, I can write V average or V bar. V bar will also give you what? It will also give you the average velocity. So V bar equals to, so what you can write? You can write total displacement divided by total time taken. Okay. So this much displacement has taken in what time? In a time interval of delta t. Okay. Displacement has taken in time interval of delta t. Okay. So if it is a very small time interval, so you can say it is delta t. So this is what going to be your average velocity. Okay. So if I replace delta r by its value, so V bar equals to what is there? It is delta r divided by delta t. So I can write it as V bar equals to, so what is delta r? Delta r is delta x I cap plus delta y j cap. Okay. So you can write it as delta x I cap plus delta y j cap. Okay. So divided by delta t. So V bar is equals to, so delta x by delta t. Delta x by delta t I cap plus delta y by delta t. So this is what z. Okay. So this is what delta x by delta t is nothing but average velocity along x axis or x component of average velocity. So can I write as Vx bar I cap plus Vy bar j cap. So Vx bar is what? It is nothing but the x component of average velocity, and Vy bar is what? It is a y component of average velocity. Okay. So this is what going to be your average velocity. Suppose if I apply limit, if limit is applied, so what will happen if limit is applied? So V bar equals to limit of delta r divided by delta t. What is the limit? Limit is delta t is very small, it tends to 0. delta t is very small, it tends to 0. What limit you are applying? Delta t tends to 0, so I am applying here delta t tends to 0. So v bar is equals to, what is this? This I can write it as dr by dt. Okay, so when you apply the limit, you can directly write it as dr by dt. When limit delta t comes, when it becomes 0, that means you are dividing the displacement with very small intervals. Okay, so when you divide the displacement with a very small interval, this small interval will give you what? Instantaneous displacement. Okay, instantaneous. If you are taking instantaneous displacement, velocity will also become what? Velocity will also become instantaneous velocity. Okay, so on applying limit delta t tends to 0, average velocity will become instantaneous velocity. So instantaneous velocity v equals to dr divided by dt. So from where we got it from here only. Okay, so here also in place of dr, you can again apply the whatever delta x by delta t and delta y by delta t, that we will see. So this is what the instantaneous velocity. Then you may think of what will be the direction of this one? What will be the direction of this v? Okay, so suppose for that, before going for let me go with the direction also. Suppose you are having this is x and this is y. So there is some displacement, say this is the point P and this is P dash. So there is a displacement like this. Okay, P to P. This is what delta r. Okay. So now what is the resultant direction? Resultant of these two vectors. Okay, so resultant of delta r is what? Resultant of delta r is, say one vector is in this direction, another vector is in this direction. So resultant is what? Resultant is in this direction. Okay, so if delta r is in this direction, obviously velocity will also in this direction. Okay, if delta r is in this direction, velocity will also in this direction, because it should be in the direction of displacement. So the velocity direction is this one, direction of velocity or direction of v. So it is going to be here. Okay, suppose if I make delta t very small, suppose this is what x and this is what y, and delta t if I make very small, this is what. So now what will happen? This is what displacement, this is delta r. Okay, so now if you look at the resultant now, this is r and r dash, so this is one and this is another. So this is what the vector, this is what the delta r. Okay, so again if you look at the direction of r, delta r is little will be this direction. Okay, so this is what will give the direction of velocity. So direction of velocity will become here. Okay, so the little it is coming down. Okay, suppose if I make it very small, so this is one and this is vector, this is what going to be displacement. Okay, so if it is very small, so what will happen again? This is what, and this is going to be vector of displacement. So this is what delta r. That means it is going to be only here. Okay, it is almost along the curve. Along the path. So velocity is going to be here. Direction of velocity is going to be here. So this is what velocity. Okay, so if I make delta t tends to almost zero. So what will happen? If I make it almost 0, this is what x and this is what y. So what will happen? So curve is here. Okay, so some curve is here. So you are making it delta t almost 0. Okay, so if almost 0 means how we can get the direction of velocity? It is almost along this line only. along that curve only. So how you can get that one? You can just draw tangent. Suppose if you draw tangent over here, you will get the velocity direction. Okay. So tangent and give when delta t is very important, when delta t tends to 0, the tangent to the curve gives the velocity or direction of velocity at that point. Okay, so note this point: when delta t tends to 0, the tangent to the curve gives you direction of velocity at that point. Suppose there is a curve like this. So tangent here will give you the velocity. Okay, tangent here will give you the velocity. Tangent here will give you the velocity. Okay, that is the instantaneous velocity. Remember, this graph will give you what? Instantaneous velocity. Here it was average velocity. As you go on decreasing the time, when time interval go on decreasing, so what is happening? It is becoming instantaneous velocity. For instantaneous velocity, direction is what? Direction is nothing but tangent drawn at a point or at one point of the curve. Okay, that will give the velocity direction at that point. Okay, so no need to worry much about those things. Just remember, if you draw the tangent to the curve, that will give the instantaneous velocity. Okay. So what is this? V equals to dr by dt. Let me come in reverse order. So what I am doing is applying limit. So you can write dr by dt like limit delta t tends to 0. So you can write as delta r by delta t also. Okay. So limit delta t tends to 0, delta r by delta t. I can write it as delta x I cap. Delta x I cap plus delta y j cap divided by delta t. Okay. So now you apply this limit to both separately. Okay. So limit delta t tends to 0, delta x by delta t I cap plus limit delta t tends to 0, delta y by delta t j cap. Okay. So can you write this as delta x by delta t, limit delta t tends to 0, I can write it as dx by dt I cap plus dy by dt j cap. Okay, so this is what the velocity. So instantaneous velocity is this is the velocity along x-axis. So I will write it as vx I cap plus this is velocity along y-axis. So this is vy j cap. Okay, so again you can simply write velocity equals to v equals to vx I cap plus vy j cap, where vx is dx by dt and vy is dy by dt. Okay, so this is what for the final equation you got for the velocity vector. Okay, then how you can find the resultant of that one, because it is in the vector form and you already know how we can write the resultant, that is magnitude of the vector and direction of the vector. Okay, so how we can write this as v equals to vx I cap plus vy j cap, vx I cap plus vy j cap. So how we can write the magnitude of velocity? So magnitude of velocity you can write it as v equals to square root of vx square plus vy square. Okay, then what about the direction, angle made with the x-axis? Okay, so how we can write angle made with the x-axis, or for direction you can write it as tan theta equals to Vy divided by Vx. It is just like this is the triangle, this is what Vy and this is what Vx. So tan theta equals to opposite divided by adjacent. So this is what? So theta equals to tan inverse of Vy divided by Vx. Okay. So again remember these two equations help you a lot in finding the resultant velocity or direction in many cases. Okay. So let me go with one more physical quantity, that is what? Acceleration. Okay. So acceleration. Okay. So how we can write acceleration in terms of vectors? Okay. So usually for average acceleration, so how we can write? A equals to delta V divided by delta T, because it is nothing but what? It is nothing but rate of change of velocity with time. Okay, so average acceleration equals to, so not a vector, so average means A bar. Okay, so delta V, what is delta V? So delta I will write as it is outside. V is what? V is Vx I cap plus Vy j cap. Okay, so Vx I cap plus Vy j cap, so divided by delta T. Okay, so A equals to delta Vx by delta T I cap plus delta Vy by delta T. Okay, so what is this? This is going to be j cap. Okay, so you can write it as average acceleration is equals to, this is what? Rate of change of velocity along x, that means acceleration along x I cap plus acceleration along y j cap. Okay, so this is going to be what? This is going to be the average acceleration along the along the x-axis. Okay, so here what? Ax is what? Ax is delta Vx divided by delta T. Ay is delta Vy divided by delta T. Okay, so suppose if I apply the limit for this one, what will happen? So apply limit delta T tends to 0. So what will happen? Acceleration equals to limit delta T tends to 0 delta V by delta T. Okay, so can I write this directly? So apply limit, so you can substitute over here, apply limit separately for both. Okay, so limit delta T tends to 0, so delta Vx by delta T I cap plus limit delta T tends to 0 delta Vy by delta T. Okay, so this is what instead of writing this step directly, I am writing this one. In place of delta V by delta T, I have written this one, limit as it is, I am applying for both. Okay, so now what is this? Limit delta T tends to 0 means this delta Vx by delta T will become delta Vx by dt, sorry, dVx by dt I cap plus dVy by dt j cap. Okay, so this is what? Acceleration. Okay, so simply you can write A. So this one instantaneous acceleration, it is going to give you instantaneous acceleration. So you can write this as Ax I cap plus Ay j cap. Then you may ask me what is the difference between these two equations. So here it is giving you instantaneous acceleration along the x. Ax is dVx by dt and Ay is dVy by dt. Okay, so this is what? This is going to give you what? Instantaneous acceleration. Okay, so A equals to Ax I cap plus Ay j cap. Okay, if I look at the direction of acceleration, suppose this is what some curve. If I take some curve over here, so point P and here P dash. We already know direction of velocity is what? Along the tangent drawn. Okay, so this is what V and this is what? P dash. Now you make the vector form of this one, V, and this is what? P dash. Okay, so what will be the direction of what is the direction of what will be the direction of your acceleration? If I take one more here, another here, so that v dash, okay, sorry v. So what will be delta v? Delta v will be here somewhere. Delta v will be here, okay. So v plus delta v equals to this is what v dash. This is what v dash. So v dash minus v equals to delta v. So this is what direction of delta v. As we know, acceleration is not delta v by delta t, so it should be in the direction of delta v. So direction of acceleration is this one. This is what direction of acceleration. So direction of acceleration will come here. Okay. So all based on your vector triangle of vector direction. If I make a time little smaller one, suppose it is like this. If I take p over here, it is p. So p will be here. So this is p, and p dash will be here. So I will take p dash will be here. Okay. So now how we can do this one? P dash in this direction, that is p dash. This is v. P dash will be here. This is what direction of p dash. And what is the direction of v? Direction of v somewhere here. Direction of v is here. Okay. So now what will be the delta v? Delta v will be here. Delta v will be here. That means acceleration is along this direction. This is what going to be acceleration. Little becoming perpendicular. Little becoming perpendicular. Okay. So if I take delta t tends to 0 only, so now what will happen? So if this is the curve, if delta t you can take very small, if this is the displacement, so this is what velocity, then where will be the acceleration? Acceleration may be here, perpendicular to this one, because in case of your one dimension, acceleration is always what along the displacement or change in velocity. But here we and in two dimension, velocity and acceleration can take angle, can make any angle, between v and a. Between 0 to 180 degree. Okay. So if v is here, a may be here, anyway. A may take all these values if v is here. Okay. So in case of your one dimension, in 1D, what will happen? V and A are always same. Most of the time V and A are going to be in the same direction. Most of the time. Change in displacement and velocity, acceleration are going to be same. But here they may take any value between the